This is Heath Kocan. He graduated from the Oregon Institute of Technology, and he works here at CEC as an engineer. And he's here to talk to you guys about hydropower and getting Cordova down to zero carbon for its electricity. Is that kind of the...
Yeah.
All right. Cool.
All right. Well, Clay was scheduled to give this talk, but there was a emergency board meeting, so now you're stuck with me. And the title is Cordova Net Zero. Basically, I'm going to talk about what we're looking at the co-op to get us off of diesel, and that's our ultimate goal. At least one of our goals right now is getting us off of diesel, and I'll explain. Obviously, I'm sure off the top of your head you can probably understand why we want to be off diesel, but I'll explain in more detail. Whoops. There we go. First, I'm just going to explain how we get our power in town. If you don't know, I won't spend a lot of time. If you have questions, just raise your hand. So as you can see here, hydropower. We have two hydropower plants, Power Creek and Humpback Creek. Currently, we get roughly 61% of all of our energy from those two plants. It's been as high as 80%, I believe, in 2009, but that was a really wet. It was 8 or 9. I wasn't here, but it was a really wet year, so we had really good hydro production through the winter. But on average, it's around 60 to 65%.
Do you know how much sort of extra hydro gets produced that's not used, like as far as
yes.
kilowatts?
We produce about 17 million kilowatt hours roughly, and we spill on average of about 3 million kilowatt hours. Which that's another thing we're kind of looking at. You know, that's a tougher one to capture, that spilled water, because it has to be
stored.
Not necessarily stored, but it needs to be something we can turn off, which I'll talk about a little later. Orca Plant, which I'm sure most people have seen by the ferry, we get about 40% of our power from Orca Plant, and that's all diesel. Although that's changing a little bit, but 99% of it is all diesel power. And in Cordova, the average Cordova home uses about 6,000 kilowatt hours a year, just for reference. It's a lot less, like in the lower 48, especially like Northwest where power is really cheap. They use about 15,000 kilowatt hours a year, but they're also paying 9 cents a kilowatt hour as opposed to our 20 to 50 that we paid here.
And they're probably heating their homes with it.
Yeah, especially in like the Northwest, there's a lot of electric heat.
I don't know if I've ever paid 20.
It's been a long time.
Yeah, well, someday hopefully we'll be there. I know we're not there right now. So Power Creek is our largest run-of-river plant. It's a 6.3 megawatt capacity. There's 2 generators there, 2 big turbo turbines. It's road accessible. 2012 is about a little under 13.5 million kilowatt hours were from that plant. And you can see it here. There's a little reservoir. It's not very big. There's no storage. It's all run-of-river. So when it stops raining or snow stops melting, we run out of power up there. And this rubber dam, we can raise and lower if we need to spill water for different situations.
Is there some days where it doesn't produce any water or any electricity at all?
Yeah, this last couple of years, there's been some periods, when the temperature drops, like in March, April. There's a point once the flow gets too low, there's not enough flow to keep the turbines going. That's down around 8 CFS. We get below 8 CFS, and we can't run the plant. There's not enough water, and it's rated up to 350 CFS. So when we have, like a couple weeks ago when we had all that rain, we were spilling. In this reservoir, we keep a certain level. It stays at 7.5 feet. We don't want it to go over that. We don't really want it to go below that. 7.5 feet is like our optimal point. And this dam will raise and lower depending on the water level. When we had all that rain, was a couple inches of rain on Saturday 2 weeks ago. There was above this dam there was 3 feet of water going. It was 7 feet tall, and the dam was, down at 4 feet.
What's the logic behind that? Why not store 3 feet, as big as that place is, that much water?
The problem is you don't want water spilling up over the intake. So 7.5 feet. The river comes down
Yeah.
right to the intake, so we can't store water there. and with our license, we can't store water. With the FERC license, it's a run-of-river project, so we can't store water. And unfortunately, Powder Creek isn't good for storage because it's a really porous basin. It's basically from earthquakes and different things. So it's if you go to the project, you can see where around the dam, water is accreting through the ground and coming out. Our newest plant that just went online July of 2011 is Humpback Creek. It's smaller. It's only 1.25 megs. It's remote access. There's no road out there, so we have to take a boat, which adds to costs, unfortunately. The good thing is it's fully automated. In the old days, you used to have someone stay out at Humpback Creek 24/7 in the shack out there and go up and check on the plant. This one, since it's been in operation, they go out in the winter once a month sometimes even. We have cameras so we can watch the whole plant, and everything's censored. So they can sit at Orca on the computer and watch the plant, and they can look at the turbines to make sure water's not leaking. And it's a pretty nice plant, and it's working pretty well.
How many turbines are out there?
3.
3.
Yeah.
So sometimes one's running, or sometimes all 3's running?
Yeah, so there's 2 500 units and one 250 unit, 250 kW. So it'll, depending on the water level, like middle of summer, all 3 will be running. Right now, just 1 is running because of the water we have available. If it rains, then another unit will come online. I'll talk about that a little more later.
So can Humpback Creek continually produce electricity throughout the whole year?
No, it's run of river, just like
so it
Powder
gets
Creek.
too low even for the 250 kW.
Humpback Creek, it didn't shut off last year. It ran all through the winter. There was enough water. Just because the problem is at Powder Creek, they're so big. If you could, I don't know if you've ever been up there to the plant. So at Humpback Creek, it's a 250. The smallest unit's 250 kW. It's about half the size of this table, and it uses 2 jets. So the water comes in, and there's 2 jets, and there's a wheel with cups on it, and those jets shoot the water into the cups, and then it spins that wheel, and that spins the generator. The units at Powder Creek, 1 unit is about the size of this room, so it's a really big wheel. The jets, the nozzle opening is about that big, whereas on Humpback Creek, it's about that big. So you can, if it's lower flow, Humpback Creek will keep going. And we get about, last year we got 3.5 million kilowatt hours. This year we're looking to do better than that, as long as it isn't a cold, dry fall. Just go over the hydro numbers one more time. So we had, 13.5 million kilowatt hours, which at 6,000 kilowatt hours per year, it's about 2,200 homes, enough energy for that many homes. We offset over 1 million gallons of diesel fuel. At the price we get, we've negotiated for a little lower rate since we buy so much fuel from shoreside, but that's about a $4 million savings in diesel fuel last year from Powder Creek. And about a little under 4,000 tons of pollution that we didn't have to send up the stack because we didn't have to run diesels. Humpback Creek's a little less, about 600 homes. But again, 260,000 gallons of fuel, about $1 million. So you add those 2 together and it's a pretty good savings. Because that diesel fuel, that goes directly, to the customer. And of course the pollution savings. Orca Plant, we have 5 diesel generators. They range in size from 2 meg to 1,000 kW units. All the way up to this one here is our newest generator, and it's 3.5 megawatts. We have 11.5 megawatts is the capacity down at the plant. Last year we burned 811,000 gallons of fuel, which is still, it's quite a bit, which basically you all end up paying for. And at the Orca Plant, just a couple years ago, we put it in, and it's just getting going now, is our heat recovery unit, which basically I'll talk about it later, but we're taking, in the diesel process, you only get about 30% of the energy from that fuel. So we're trying to get a little more out of that by getting the heat off the engine and trying to turn it into electricity.
Is that the unit that's exterior to the building?
Yeah, that new building that's off to the right. This is what it looks like inside the building. So basically what happens is the diesel engine's running like a car engine. That hot water that's the cooling water that's going through the engine that normally we run out to the radiator and all that heat is just kind of blown off into the atmosphere. We're bypassing that and running that same fluid coolant that's heated, and it comes into this bottom tube, which is the evaporator. And in that evaporator, there's a heat exchanger, and we have a glycol solution that then that water flashes off the glycol. Since it flashes at a much lower temperature, it goes through the generator, basically turns to steam, goes through the generator, and then spins a turbine, and then powers a generator, and then goes back into the condenser, where there's, if you drive by the power plant, you'll see a big cooling tower in the back. That's where we're sending cool water in to cool down that glycol solution to send it back to the evaporator and kind of keep that cycle going. It's rated at 250 kilowatts. So far, we've only gotten 140 out of it. So that's something, unfortunately, we can't test it in the summer because it's connected to our biggest diesel, which we don't want to run if we don't have to because it costs a lot of money. But that's something we'll be doing this winter is trying to optimize our heat recovery system.
And you can't send every single generator through there, it's only the one stable?
Right now, we're looking at connecting the other units. The problem is diesel, the temperature of the diesel is about 190 degrees, that coolant, which is right at the bottom end for these heat recovery machines. So we wanted to put it on our big unit first, since it produces the most heat, and make sure it works before we did all the plumbing to connect all of them.
And you can't use the exhaust, you just use the coolant?
They looked at the exhaust, and the problem with the exhaust is that if you take heat from the exhaust, you lower the temperature of that exhaust. So you have a lot of particulates in exhaust. If it's really hot, those particulates rise up and are dispersed better. If you cool that exhaust, it doesn't rise up and those particulates don't spread as far.
Right, but if you then burn less diesel fuel to create the same amount of electricity, then
Yeah, I mean, part of it is because with this, we don't have to deal with the EPA. If you try and get it from the exhaust, you have to deal with the EPA. Right now we have a Title V permit. If we did that, we'd have to get 2 other permits. And those permits alone, every 3 years we have to renew them, and they're about $40,000 to $50,000 to renew those air quality permits. So it just, cost-wise, this was all grant funded by the Alaska Energy Authority. It was kind of a test bed. They wanted to see if no one had ever hooked up a heat recovery unit to a diesel engine. So it's kind of a test in process.
what's it usually hooked up to?
Normally, you'll
Geothermal?
geothermal. They'll have 20 of these units all lined up, hooked up to a geothermal source.
So is that that's the waste heat exchanger, and then your engines also turn generators.
Yeah.
The diesel engine itself turns a
Yeah,
generator.
the diesel
This
is
just the
connected
waste
to a generator set, and then we're just pulling off that jacket water to get a little more energy out of it.
heat. Right.
Now, what's the vendor support issues?
The problem we're having, this company Pure Cycle, which is where the state got the unit from, they were owned by Pratt & Whitney. They now sold this Pure Cycle section to Mitsubishi, and Mitsubishi is contemplating not just dropping it all together. So it's, right now we're having trouble getting support. When we have problems, we're trying to figure stuff out. This had never been done, and we needed to see if it worked. If it turns out and it starts to work really great, then it doesn't help us as much as especially Western Alaska, where they're 100% diesel, or Yakutat, where they have no, there's no hydro, no wind. This is really the only thing that can help them use less diesel.
So, I thought I read up at, is it Chena or Circle, Hot Springs, where they're running some sort of geothermal off 150 degree water or something.
Yeah, they are using units similar to this that basically Bernie, I don't know if you know, Bernie, I forget.
Carl.
Yeah, who owns it. He's taken a unit like this and broken it apart, and he's tweaking it, modifying it.
Right, and it seems like if you can find a cool, instead of glycol or something that flashes at a lower temperature.
Yeah, and that's something we're gonna look at. We're gonna, once we get back into diesel season and we can run Unit 7 and we can fire it up and we can play with it more. some of the problems are, you know, when we worked with Pratt Whitney, everything was proprietary. They didn't want to tell us how anything worked. But now that they're kind of out of the picture, we can basically pull it apart and figure out how it works and tweak it to our needs.
So at this point in time, would you say that it'd behoove a private individual to take over this situation from you guys, or are you gonna be able to keep it running? I mean, you're gonna have to assume that you're gonna get no support whatsoever, you know.
Yeah, I mean, right now it runs right now. We're not getting the optimal performance out of it that we should. The two things you need to look for was the inlet tap needs to be around 190 degrees, and you need the right amount of flow. You know, if it's flowing too fast, you can't pull the heat out of that water. So we sent all our data. You know, we collect data on our system. So we have 1 second data for all the different points on our system, and we sent it to the different companies. You know, and they said that it's a good match. There's the right flow and the right temperature coming out the engine. So there's some things we need to look at as far as, are we actually getting the right flow that the manufacturer from EMD said off the engine? So there's things we need to look at and work with the state, and if it doesn't work out, then the state can have it back and we'll move on. So this is just kind of showing where, in 2012, where the dollar came from that we're pulling in. You can see most of it's commercial, processors, and then residential. And then on the next slide, you can see where the dollar went. So 40% of every dollar that you send to CEC goes to shoreside over the course of a year. Obviously, if you're just here in the summer, it's very different. But if you're here year round, 40%. And then this bigger chunk here, 19%, which is power production. I think some people don't always realize that it costs a lot to generate power. You know, if you're in the lower 48 and you're in a co-op where you can just get energy off the main grid, you can see how much of the pie you don't have to pay for. Whereas here, we're having to pay for generating our own power. And the bulk of that is diesel fuel. And this is just a little chart showing our expenses over the last 10 years and then diesel fuel. And I don't see diesel fuel dropping in price. It might, but I really don't see it dropping that much. In the long term, I think it's just going to keep going up. So why do we want to focus on reducing diesel? Well, the expense, it adds about 30 cents per kilowatt hour to your rate, and that depends on the price of diesel. Obviously, if the price of diesel drops, if we find a bunch in Texas again, that will drop and it'll be less. Air quality, like I was saying earlier, we have to file those air quality permits. Right now, there's different levels of the permits. So we're less than 12 megawatts of diesel. We're right on the edge, we're 11 and a half. Our loads this year were the largest they've ever been. We reached peaks of about 8.7 megawatts. Before that, our biggest peak was 7.4 megawatts. Granted, there was a lot of fish, but the processors have also said that they're gonna install more capacity. They're automating a lot more, so that more machinery and more load. They expect their loads to be the same next year, even with less fish, just based on the extra machinery they're adding to their plants. Which means that if we get to a certain point, like this summer, when we had to take the hydro offline for maintenance and different things, we had all of our diesel generators running. And if one of those generators were to die, that means we have no backup. So we're getting to the point where we need to add more diesel in the event that, if load keeps increasing, we need that backup, because you don't want to be 100% diesel with no backup generator in the middle of.
Or, well, why does it have to be hydro or diesel? Why can't we? I mean, I'm just saying, it seems like one or the other. Isn't there other options?
Yeah, I'm going to talk about those. I'm just kind of explaining one part of it right now. If we have to, once we go over 12 megawatts, if we have to add another diesel generator to cover the load growth in the summer, we have to go to a Title I permit, which costs about 3 to 4 times more than the Title V permit, which is already pretty expensive. And it takes about 2 years to get the whole permit done, and you have to have lawyers, and it's a big pain in the butt. Of course, the negative environmental impacts of diesel, the energy security. It's better to be, hydro, wind, or things that you don't need fuel for from foreign countries. High maintenance costs. and high operation costs. All right, so now I'm going to talk about some alternatives for diesel that we've looked at and are looking at. Improving our diesel efficiency is not going to get us off diesel, but it'll help us use less diesel. Improving our hydro efficiency. There's different ways we can optimize our plants a little better. Small scale grid regulation and storage, which is batteries, small hydro, flywheels, and micro turbines. And then there's non-firm renewables. And when I say firm, there's firm power is like a diesel generator is firm, hydro is firm, because as the load changes, we can follow it. So if everyone turns on their toaster oven, we can put more fuel in the diesel generator and it produces more electricity, or open the nozzles on the hydro. Non-firm is wind, solar to a certain extent, tidal power. You can't control it, so the wind could be blowing and all of a sudden everyone turns a bunch of stuff on, but the wind could stop blowing and you can't make it blow any harder. Biomass, a little bit too. And then transmission, we've been looking at, well, can we just connect to a larger grid instead of putting more infrastructure on our system? Can we connect to, Valdez or Whittier and pull power from another source where they can make it cheaper than us? And the last one would be hydro storage. All right, improving the efficiency of our plants. One thing we're doing currently is these are, I don't know if anyone has worked or been around big diesel engines, but when you rebuild them, you just pull, this is called a power pack, so that just pulls out of the cylinder and you pop a new one in. I mean, there's more to it than that, but then that's kind of your rebuild. The newer piston designs, they have better rings, so we use 2-cycle diesel engines, so we burn oil as well in the engine. These have better rings, so right now I think it's about a gallon. Actually, don't quote me, I don't remember the exact figures. Basically, we're going to cut our lube oil costs in half with the new piston design, is what they say. Another thing is improving our diesel dispatch. So this is the SCADA system, supervisory control and data acquisition, is what controls our plant. So our plant is totally automated. We only have guys at the plant from 8 to 5 on the weekends, and at night it's not manned. The system just controls itself. And this is demand control. So as the load goes up, it switches between different units. And there's hydro units and diesel units. And if there's no water, then obviously there's no hydro. So there are things we can do to look at the data and see where we can tweak that to get the best performance out of the system. Another thing is Powder Creek intake screen. Unfortunately, when they designed Powder Creek, it was a really bad design. And what happens is the river comes down, and then the bladder, the dam would be right here, and this is the intake. Well, basically it creates an eddy right there. So when the water comes around, any twigs or branches come and they hit that eddy, and then they go right into the screens. So in the fall, if it's a wet and windy fall, we have to people go up there and rake the screens. Otherwise they get clogged. And also, you can kind of see those little posts sticking out of the water. Right in front of that is where the creek bed is, and because of that eddy effect, gravel builds up there. And especially when we have big storms, like a couple weeks ago, what ends up happening is we have to we have to dump the dam. So it's you'd think we have a lot of rain, okay, you can be 100% hydro, but when we get those big storms, we're actually probably running a diesel generator. Because the gravel builds up and it clogs. If it builds up too much, it'll spill over those metal posts. There's a little dip down in there, and if it gets in there, then they have to go up and shovel it. And there's been times when if they don't catch it, they'll be shoveling for a long time. So what they have to do is basically turn a diesel on over here, usually our big unit, bring it on and take the load of the town, drop the dam, turn the plant offline and let all that flush out. And then once it's flushed, they raise the dam back up and turn the plant back on. So we're looking at improving that intake structure to decrease downtime and decrease the maintenance that's needed up there. Another one is the in-stream flow. We have to release 5 CFS all the time. That was part of FERC. And there was really no, it was just something where Fish and Game and FERC got together and said 5 CFS. They just kind of picked a number. Well, that 5 CFS, during the winter when I said we have to shut the plant down because we don't have enough water, that 5 CFS would allow us to keep it online. And it's so porous that so much of the water goes under the ground and then comes back up just below Omen Falls. So we have a stream gauge, and we're finding that right above the power plant, we're getting about, even in those low flow periods, we're getting, 15 to 20 CFS of water coming down. So we're working with Fish and Game to try and get rid of that 5 CFS requirement. And then we can at least, be getting power from the plant all year long. Unfortunately, working with state and federal agencies just takes a long time and is a long process. Our heat recovery plant, we are, like you asked, we're looking at, once we get it working right, we don't want to pipe it into all the other units unless we know it's going to work well. All right, small grid storage. When we look at grid storage, there's two things. There's regulation and quality, and I won't get into this too much because it would take a long time. Even it's a concept I have trouble understanding all the time. Regulation, quality, and storage. So in the summer at our Powder Creek plant, even though it's rated for 6.3 megawatts, we only run it at 5,800 when there's enough water available because we need a buffer. We have a 500 kilowatt buffer. So basically, if the ferry comes in and plugs in all of a sudden and doesn't let us know, we need to have enough power in reserve to give it back to the system. So I don't know if does that make sense to everyone? So if we're looking at different things like dispatchable boilers and different stuff, that's where we can actually use that 500 kW that we're just having on reserve that we're not using. If we have boilers or different things we can turn off and on, we can be heating water, but then if we need to switch that power and give it to a cannery real quick, we can. Dispatchable boilers, micro turbines to a certain extent. A flywheel would be the same. So if we had a big flywheel or a series of flywheels that was our 500 kilowatts, we could run Powder Creek at a higher rate, and we'd basically have flywheels sitting there spinning, and they'd be holding the energy. And when we needed that energy, the flywheel would release the energy onto the system and keep everything going. Small hydro we're looking at as well. Hydrogen and ammonia, I don't think hydrogen, it just doesn't look like it's panning out, but anhydrous ammonia is something people are looking at. They're able to electrolyze anhydrous ammonia, which we could burn in our diesel units. So if the technology improves, there's a possibility where in the summer when we have all that excess hydro, we could be making ammonia and storing it in tanks. And then in the winter, just burning that in our diesel units. It's not quite there yet, but that's another possibility. Batteries, I'll go into those a little later. There's good things and bad things about batteries. All right, the boilers, there's different kinds. This one in the upper right-hand corner is more something you'd have in your home. It's actually a heater, not really a boiler. It has a bunch of ceramic bricks. So the concept there is at night when we have lots of energy that we're not using, we can sell at a cheap rate. You can heat up these bricks, and then during the day, those bricks hold the energy, and during the day when you need the heat, the bricks can slowly release the heat into your home. And the bottom one is similar. It would work at the canneries. Before their boilers, they would have one of these big commercial units, basically a bunch of bricks, and they'd run the water through it. And it would heat up, it would preheat the water before it goes to the boiler, and that way they wouldn't have to use as much diesel fuel to heat the water up.
So you're talking about differential pricing to encourage people to do something like the top boiler?
Yeah.
And that would be that.
And we have that rate in place, we just haven't found a customer for it yet. I thought the canneries would want to get onto it, but I think we're gonna have to do most of the legwork.
Well, I think the whole town would if we could use more electricity during an off-peak time.
Yeah, unfortunately, all our hydro is in the summer. I wish we had more hydro in the winter, because this would be great in the winter, if you're heating your home. You don't need the heat as much in the summer around here. Micro hydro turbines, they won't really do a whole lot for the cooperative. They're great, you know, if you live in different parts of town where you don't have electricity, like I know Hippie Cove Hoots has one, and some other people have some little micro turbines. This is a diagram of a flywheel. So basically it's just a motor, a solid mass that spins really fast at about 30, well, the new ones that are composite, you know, carbon fiber and all this magnetic bearings so nothing touches, they spin at like 35,000 RPMs. So it's whipping around. The more classic, which is basically just a big hunk of iron, you know, spins more around the 10 to 15,000 RPM range. But the newer, more advanced ones are pretty slick.
Is it winding a spring or is it just?
No, so basically it's just a big mass that's spinning. And, you know, it takes some energy to get it going, but once it's spinning, it doesn't, you know, just a little burst to keep it going. And then, so let's say the canneries come online with something, and we need more power right away. You have that spinning mass, and then it basically just slowly slows down as you're pulling the power out of it.
What's driving the spinning action?
So it's basically a motor. If you imagine an electric motor, you know, you've seen them
Why
spinning.
don't they use the turbines on the, like we do in the boat, that little turbo? On my boat's turning 20,000. And you could certainly look it up to something like that. Use the exhaust of those diesels if you're using them.
This would be a little too big for that. Like this unit, these are made in Massachusetts. I forget the name of the company, but it's about 15 feet wide
Oh, wow.
and 30 feet tall.
Boy, that
So
sucker
it's-
must weigh a bunch then.
It weighs a lot. They're big units.
When you get one that big, I mean, it's a big boy, three stories tall.
Yeah.
When you get it going 35,000 RPM, how many kilowatt hours can you make? I mean, if you just turned it on, I mean, how long do you think it'd go?
I think they're rated at 2 megawatts. I don't know the duration, but it's a big unit.
Yeah, I was gonna say that RPMs.
And it really depends, you know, it's rated at 2 megawatts. That's like its power. The energy in there, the megawatt hours would depend on, you know, if you pull a full 2 megawatts, it's probably not real long. But if you did like, you know, 800 or 0.8 megawatts, it'll give you power for a lot longer. So, battery energy, we've been looking a lot into it. The nice thing is it's easy to integrate. Like they make basically a semi-trailer that has a bunch of batteries that you pull up to your substation and plug it in. I mean, there's more to it, but it can be that easy. The problems is really the lifetime. You know, those are like lead acid units, so you get maybe 10 to 15 years before you have to replace the batteries. And especially on our system where there's such big changes, it would cycle a lot. So we probably get even less time out of it. You could go with like a lithium ion battery, but then your cost is gonna be about 3 times what it is of the lead acid system, so.
And the lead acid, you can't sort of refill the acid, or?
No. I mean, after a while, the plates electrolyze and you need a new battery. And on to renewables. Obviously there's wind, solar, tidal, biomass. Unfortunately, they're hard to compete with hydro. If you have the option of hydro storage, like a dam, where you can have a big reservoir, it's really hard to beat that for electricity. And they have a low return on investment compared to other options. And of course, land and environmental barriers. I mean, that's with any technology, really. And transmission issues, at least around here. So this is a picture of, the green is the wind speed. And this is from the native village of EX data. And the blue is the load in town. And you can each little hump is a day. And you can see how the wind varies. It doesn't follow that load necessarily. And the other thing with wind speed is the power you get out of it, it's a cubic relationship. So, you know, you're gonna get a lot of power, obviously out of those big spikes, but down here, you're not gonna get very much power out of that wind. And this just kind of shows the wind distribution. The red is the wind speed, meters per second, and then the blue is the energy you get out of that. So at your optimal point, right around 10 meters per second, you're only getting that 3% of the time over the course of a year. So you're not getting a lot of energy out of that wind. And then solar, I'll explain this chart real quick. So this is NREL, National Renewable Energy Laboratory. They're a big federal agency. They do a lot of renewable research. And around here, we're looking at about 3 kilowatt hours per square meter per day. You figure a house uses, what did I say, 6,000 kilowatt hours a year. So you need, it doesn't work in Cordova. If you just live here in the summer and you're off grid, yeah, solar I think could work in Cordova. You live here year round, it's just not really worth the investment, because it's, if you're looking for a single family home, and this is in like Oregon where I went to school, it was about a $12,000 to $15,000 investment in all the, batteries, wire, panels. Up here you add 20%, 30% for freight. It's a big investment to only get us power half the year. And then of course tidal. I know a lot of people around here talk about tidal because we have lots of water. The problem is the technology is just not there yet, and it's probably not going to be there for a long time. You run into the issue of, well, this is kind of the more common design they're coming up with, is basically turbines underwater. I don't know if people would like that around here with fish. I don't know if it would be worth it or not. The other problem is you have something that's in the water, the maintenance is just a nightmare. Especially salt water, yeah. I mean, yeah. It's just,
Are the tidal, are they designed to go dry? So we have such dramatic tidal range here.
like that unit. I don't know if I can go back.
If you use the scroll wheel, I think you can.
Okay. Oh. So the design they're coming with now is it's like a pole, and those two units ride up and down on it, so that when they need to do maintenance, they can pull it up out of the water, do the maintenance, and then put it back down. Or, if they knew, like if it was an icy situation or there's lots of debris, they can pull it up for those periods. And we also have been looking at, okay, can we connect to somewhere else? And of course our options here are Valdez, Yakutat, and Whittier. Well, Yakutat, there's no real reason to, because they're 100% diesel, wouldn't really save us any money. Valdez, they're an islanded system. We could potentially get power a little cheaper from them at certain points in the winter, but there's times in the winter when they're 100% diesel. For this submarine cable, and it's actually more now, but uninstalled it's $1 million per mile. So if you look at basically we're 70 miles wherever we want to go, installed it's $2 million a mile.
Now what is that?
Submarine cable.
A transmission cable?
Yeah.
I mean, you're trying to tell me now that you paid $4 million to get the power from Power Creek to Cordova?
No, that's a different cable. This is, we basically would have to do a high voltage DC cable because of the distance. So it's a much more expensive cable than compared to, like, Humpback to here definitely was not that much. Power Creek was not that much.
I know, I was there when they put it in.
Yeah, yeah.
So
This
I
is
paid a lot of money
a
for it.
whole different kind of cable. The other thing is you have the umbilical effect. If you have a transmission line going to Valdez or Whittier, if that breaks, then you're back on diesel, so that you don't really have a good backup. And like I said, Valdez and Yakutat, they're not on the rail belt. And actually, we don't know for sure. I haven't called them up, but I don't think we could actually go through Whittier, because basically we need to be able to push about 10 megawatts of power through the cable. And I don't know if they would be able to handle that through Whittier to the rail belt. So if we had to put a cable from Whittier, to the Seward Highway, that adds even more expense. So what we've been looking at lately is Snyder Falls Creek. I don't know if anyone knows where Snyder Falls Creek is, but I'll go over that here. So this is Humpback. This is during construction. So basically what we're looking at is, if there was a road out that way, we would come up Snyder Falls Basin, or Humpback Creek Basin, and then drop into Snyder Falls, because we could have a road go up and drop in. If we were to do a large hydro project like this, having road access would cut the project costs in about half. So
What's
this
the
is,
native village, how are they progressing on that road?
you know, I don't know.
Because they're hell bent in putting that road in there.
Yeah, they are.
It'd be something to keep track of what they're doing, to work with them in it.
Yeah, I mean, I know there's different viewpoints on the road in town. I would just like to see a road to Humpback Creek, because it would, well, A, allow us the potential to put in some dam storage at Snyder Falls, and we wouldn't have to take a boat out to Humpback Creek in the middle of winter.
You're getting windy now.
So this is if we were looking downstream at Humpback, now we're looking upstream, and the valley curves up. And then if you go up to the left, there's a little pass, and then we would drop down into Snyder Falls Creek. And this is the very top. So if we went forward with this project, from talking to some engineering firms, basically we would bore a little tunnel through this pass. It's nice grade all the way up about 5%, and then there's kind of a little rock face. So basically we'd have to bore a tunnel so we could get through to the other side and then down into Snyder Falls Creek. And then here, you come up over that, and then you drop down into Snyder Falls Creek. The really great thing about Snyder Falls, and why we've put stream gauges up there and invested some money in it as far as finding out about the hydrologic data, is that, as you'll see here, you can see that nice little wall. So basically, 3/4 of our dam is already built in this site. We've looked at Humpback. The problem is Humpback is so, it's just so flat. It would take a really big dam to create any storage, and it would just cost too much money. Whereas here, it's high elevation, so from where the power plant would be to the very top is about 1,300 feet. And if you ever make it out to Power Creek, you'll see there's 2 big turbines. Well, basically we could get just as much power from here, from a turbine that are the size of this table, the ones out at Humpback, with a pipe that's 2 feet in diameter at Snyder Falls, versus I think it's a 6-foot diameter pipe, and gigantic turbines at Power Creek. So that head difference allows us to get a lot of potential power out of this project, and having that bowl where we can actually store water. And this is a little closer view of
Does
that wall.
I realize it would cut the project costs in half, but the project is feasible without road access.
We'd have to look into that more. I mean, without the road access, we're looking at basically using helicopters, and at anywhere from $1,600 to $2,800 an hour. We'd have to see if that.
You just need some Incas.
A lot of Incas with buckets.
What about the possibility of creating a road between just Humpback and Snyder Falls? Would that help facilitate or ease any
No, because
issues?
where the road being able to get to a town from a road is where we would save all our money. Yeah, unfortunately,
Are either of those, is Snyder Falls or Humpback Creek, are they anadromous fish waterways?
I know in Humpback there are humpies. There aren't here, and I'll show you why. Because basically from here, there's obviously no fish up in the alpine area here.
Right, so the barrier.
And then from here, it drops down. There's a series of falls, 1,300 feet. You can kind of see where it comes out the other side. And then this is where it terminates. And there have been fish a little further down past here. But if we built a plant, basically the power plant would be just above those falls. So any water we're taking out, we'd be putting back
Would there
into
be
the stream.
thermal issues? Are you heating the water at all
No.
out of the dam?
No, just going through a turbine and then back out. And here you can kind of see a 3D, well,
The
It's
water
2D,
is
but-
heated when it goes through. I mean, there is thermal issues when it comes out of the turbine.
yeah, it doesn't heat it up that much though. I mean,
But
ash, because it goes over that falls, it's gonna cool off quick.
Well, you might be required to put a certain flow into the stream that doesn't go through the turbines too, or not.
Yeah, we might be. I mean, that, you know, that would be up to Fish and Game and FERC to determine that.
FERC is federal?
Federal, yeah. Federal Energy Regulatory Commission. So basically, humpback is down at the bottom here. And we basically have a, if it worked, we'd have a road that would come up and then drop back down into the basin. And here, this just kind of shows the grade. You can see how coming up humpback, we have a pretty good grade until we hit that ridge. But then coming back down to the project site, we would have nice road grade. And here it is on a map, just so you can kind of picture it. You know, before I was at CEC, I know they've looked at lots of other options. I know Crater Lake has been brought up. From looking at the geology all around the area, Snyder Falls is kind of our best option for any type of dam storage. And at least with the least impact. I mean, obviously, yeah, we could do a dam at Power Creek, but then you flood that whole valley, and I don't think too many people would want that.
What about the whole Road River Valley? And then you could export energy to all
Then we
the
could
other
sell
towns
energy,
like
yeah.
Yakutat that need it.
The nice thing about dam storage and why we're kind of really looking hard at it is that it gives us that storage through the winter to obviously get rid of diesel, but also, you know, we've talked to the processors, and if we have that energy, that cheap electricity in the winter, they'll bring more fish here. You know, if you look at places like Juneau, Kodiak, once they got their dams, well, they got their dam storage. You know, now most of the fish in the winter goes to Kodiak, and Juneau can sell electricity really cheap. If we had that here, you know, it would take a while for our rates to get as low as like Juneau, obviously, because we're a smaller co-op in a smaller community, and that project would have to get paid off over time. But once the project's paid off, then you see your rates really drop. But it would stabilize our rates instead of having that big swing, you know, where we go from 30 cents in the summer up to 50 cents in the winter. We could stay at that lower rate all year round. And bring more, you know, if we can get more winter processing, it would have more jobs and help out the economy in general throughout the year. This is just a picture of the lower gauge. So we have two gauges, one at the top, one at the bottom, to measure flow. And we have about 3 years of data from the flow. So we have a pretty good idea of the resource up there. This is the upper gauge. This just kind of shows you how the flow varies over the course of a year. And based on, we took a satellite imagery of the Snyder Falls Basin. And with the hydrology data, we roughly have about 14 million kilowatt hours of storage available there. And you can see we use 10 million kilowatt hours of diesel, so it would offset all of our diesel, plus we have extra to use either in the summer, if we can get more processing capacity, or in the winter to boost different businesses. Just looking at some of the strengths and weaknesses. Some of the weaknesses, inaccessible. Right now there's no road there, so if we tried to build, like I said, it would be working on tidal land, which has a whole slew of issues with permitting as far as setting up batch plants. You know, at the bottom of that creek, we'd have to set up like concrete batch plant and then helicopter concrete up, and be a big mess. Working on Forest Service land right now, most of that is on Forest Service land. I know we've talked with them and EAC Corp, and they would, I think we could potentially work out a land swap to help get it off of federal land. Because if the way FERC works, if you build a plant that's bigger than 5 megawatts, you have to get a FERC license. So what we potentially are looking at is if we can get a land swap where it's on private land, we could build the plant where we wouldn't put in, you know, 6 megawatts or 8 megawatts right away. We would have it so it would be built in stages. That way we would be under that FERC limit to start out with, and we wouldn't have to go through that process right away. And then over time, as we needed more capacity, we could add units to the plant. Poor geology, at first we thought there might be poor geology, but we had some geologists up there, and they actually think that we haven't done any boring. That's kind of the next step, is to go in there and bore samples, but they think it should be pretty good rock up there to build. One of the big ones is the short construction season. Obviously it's at 1,300 feet, and just the position of it, there's not a huge window to work up there. Avalanche zones, tidal environment, and the small resource. Some of the strengths, it means we could be, over 100% hydro, which would be nice to not have to use diesel fuel anymore. It's high elevation, so we get that nice head differential to get a lot of power out of, less material. Using a 24-inch pipe is going to cost a lot less than using a 6 or 7 foot pipe. No anadromous issues. If we were able to build that road up and over, instead of running a submarine cable, we could trench a cable up and back down to Humpback Creek, and then push the power from Humpback Creek back to town. It would help out with the winter seafood industry. There's a Shepherd Point issue. Stream gauge, we have the stream gauge data, and we already have part of a road. When they did the Humpback project, they went about a mile up, so we have 1 mile of road already. And that's kind of it as far as what at the co-op we've been looking at to reduce our diesel. I know there's lots of things. I know I stressed hydro storage a lot. That's just because for us that's like the big, all those other things, wind, biomass, they kind of take little bites at it, but you're never going to get off of diesel 100% using other renewables and different options, whereas hydro storage is what, at least with current technology, would get us off of that. And the other thing that, at least with the electric industry, we like hydro storage. Like that Humpback Creek plant, it's made to last, over 100 years. It'll probably last longer than that. Whereas, like I was saying, battery bank, every 10 years you got to replace the batteries. Wind turbine, depending on where you would put it, you'd have to basically replace everything about every 15 to 20 years.
What's Power Creek's lifespan?
That's a good question. I wasn't here when they built it. I know it wasn't built to the same standards as Humpback Creek, unfortunately. But Humpback should be there for a very long time. So should Power Creek. Unfortunately, someone shot the bladder, so we have to repair that. Yeah.
Heath, you mentioned on one of your on your SWOT analysis avalanches, and I was thinking about your rain gauges or your water level gauges and instances like snowpocalypse. So how would a dam up there be able to handle a snowpocalypse issue or a snowpocalypse event or an avalanche?
Yeah, that's something, where when they design the dam, they would definitely look at that and make sure it could handle any type of surge. If that's when you go into the winter and look at the avalanche, if you want to look at the avalanche zones and see how it's where that's going to come down, and most of it would not hit the dam directly, but if you do have areas where it looks like the avalanches would hit the dam directly, then that's just something the design team would take into account. And it's something that FERC, if you build a dam, FERC is going to be looking at every little thing, and they're going to make sure that that's addressed in the design. And it is something we thought of, yeah. Luckily, you're up high already, so it isn't like it's a huge hillside that might come sliding down. It's going to be a small avalanche, but an avalanche nonetheless, and you'd have to address that in the design, for sure.
Outside the box a little bit, you guys seem to, stay on top of this stuff. I don't know more of it. Superconductors to, transmit the energy easier. Cold fusion, has anything come up with that? And is anybody even looking at all at a coal-fired plant down at Catella and then running a transmission line to Cordova? I mean, they already surveyed a road, so I would think a transmission line would be a pretty easy thing to put in on the old survey. And most of the world does run off coal-fired plants,
Yeah, I mean, coal's used a lot in the state. It's nothing we're looking at as far as building it ourselves. If someone some company went down there and it was feasible for them to build it. Obviously, if the power was the right price, we would buy it. But it's not
You
something.
guys haven't really looked
No.
at a coal-fired plant down there?
Because when you run the numbers, you're better off building hydro, if that option is available.
And then what about coal fusion? Is anything on that horizon at all? Have you heard anything?
It's not something we've looked at. I mean, I know they're making progress, you know, as far as making it on a small scale, but I don't know. I don't know if I would want that right over there.
Well, I mean, you can put it anywhere you want.
Right.
You know. And then superconducting transmission lines, has any breakthroughs happened on that? Have you heard of?
Yeah, I know they're working on, you know, super cooled transmission lines in lower 48.
Really?
It's more in that kind of test phase, and it wouldn't really do much for us, you know, because we'd have to run it from here to Whittier. You know, it's not going to help our system at all, because that's just transmission. It would help with, you know, okay, maybe we could transmit it from here to Whittier, but it would be, I mean, there was $2 million for the regular cable. That cable would, just off the top of my head, you know, you're probably 10 times that amount, because it's in that beginning stages. But I mean, in 10, 20 years, you never know what'll come up. Over time, though, the thing that just really, for us, is that dam storage is kind of how the only real way we can get to the point where we don't use diesel. And the other thing having a dam would do is, you know, like with humpback, if it's built correctly, it doesn't really takes minimal oversight. You know, humpback just sits there and runs. You go out every now and then just to check the packing and different things, make sure it's okay. But you know, you don't have to change oil. You don't have to do a rebuild. You know, maybe about every 30 years you go in and check the windings, make sure they're okay. So.
What would you do with your diesel generators if you had 150% of Cordova's energy needs in hydro?
That would be up to something the board would have to think about. You know, you could get rid of them, but then you don't have that backup.
Right.
But if you sold them, you can get some revenue.
Right.
Yeah, I'm not sure. The ones that are all paid off, you know, you'd probably just keep, that way you have some backup.
Right. Right. And then maybe sell the other ones that are.
Yeah, maybe your newer units
Still
that you
costly,
could get a lot more money for, you could sell
Right.
them. And,
Right.
but if you have ideas or you want to see things changed, go to your board members, because they're the ones that direct us on what to do. So.
You know them off the top of your head?
John Bocci, John Harville, David Little, Joe Cook. She's not on the board anymore. Who else is a board member? Harville, Bocci.
The guy is in Arizona.
Oh, Dan Loken and Tim Joyce. So they're the ones you need to talk to if you want to see some things changed.
What about digital meters? I read somewhere it's like most of the country has digital meters. That seems like low hanging fruit. Then you could do.
We have looked at digital metering. The problem is we don't have a big enough base to justify the cost. So we could do smart metering.
What digital metering is?
What's that?
Can you explain what digital metering is?
Yeah, so like right now, you know, we have an analog meters everywhere where we have someone comes around, reads your meter. When you have a digital meter, in the best case scenario, you don't even need a meter reader. It just gets sent to our SCADA system and we can collect all the data, billing information. But you go to bigger cities and the guy just drives around and, you know, he can scan your meter from his car. It would also allow us to do certain things like with that interruptible rate, we could control, I hate to use the word control stuff in your home, but we could turn like a boiler on and off using a smart meter, basically. The thing is the cost. You know, we have, what do we have? 1,200 meters. So for us to buy that $20,000 smart meter, and then the communications package that goes with it, we don't have a big enough base to spread that cost around. We've looked at it a lot because it would definitely help with different things, but we're too small.
I'm just thinking if you could get it so that you don't have to turn on that extra diesel generator at one point, because you can spread the load throughout could just flatten that load out somehow, and the only way I could figure it out is with digital meters. And even if we could buy our own, and I don't know.
Yeah, I agree. I mean, it would help with, on certain things. You know, one thing we're looking at with that rate is just not so much people's homes, but looking at bigger places like the pool. You know, if we had a boiler that we could turn off and on at the pool, because that, I think it's the biggest fuel source the city has, is the pool, heating that pool. Even in the summer they have to heat it.
Come on at 2 in the morning and run for.
Yeah, so at night we could, you know, basically have a heater with a bunch of bricks in it that we heat all night, and then during the day they could draw off of that. Same with the processors or any bigger building, you know, the post office or the new Cordova Center would be one whenever they would need the heat at some point maybe.
Do they just, do you know what the plan is, or they got as far as figuring out what the heat source is?
I don't know that. Yeah, I mean, there are a lot of low-hanging fruit, and that's what we're kind of working on right now, but we also, why I, you know, bring up the dam storages is that's not a project that's gonna happen overnight. If we, you know, if that's what the community wants, you know, I mean, the co-op is member-owned, so we're not gonna just go build it.
Well, we all want cheap electricity. I'm looking at Snyder Falls and thinking that maybe my kids' kids could be enjoying it.
That's the thing, you know, that's a long-term, building that would be, you know, a long-term project. Yeah, it's not gonna reduce our rates dirt cheap right now. You know, it might take 10 years to build that thing with all the permitting process. Might not even do construction for another 5-6 years. But long-term, you know, 30 years from now, when that's all paid off, or 40 years, however long it takes, all of a sudden, okay, you reach a point where it's paid off, well now your rates roll from 30 cents, now they're down to 12 cents.
Yeah, and I think I like the idea, but like 30 or 40 years down the road, we're gonna have some other technology that's gonna like blow diesel and blow hydro away.
Maybe not. I mean,
I just think 40 years ago, well, compared to what we got now, they were driving Pintos back then, you know, now we're driving.
yeah, but you look at the electric industry 30 years ago, and it really isn't that different. So, it's a different animal in some aspects, because it's just very different compared to, you know, the automobile industry. Anyone have any more questions? Well, hopefully you enjoyed it. It wasn't too boring.
It was good.
You can call me anytime if you have any future questions, or I don't know if we'll be doing any more, but I know we've been trying to get people out to Humpback Creek on tours.
Yeah.
There's a sign-up sheet.
We wanna go again. I found, we were, several of us were on the last tour. We had the best time.
Yeah,
We
it's
still
really.
talk about it. We get together and say, yeah, I remember that tour. It was so great. Yeah, we all wanna go again, you know.
And if you want to go see Power Creek, just come down and let the ladies at the front desk know, and they'll get word to Clay. And he's pretty good about, if people want to go see something, I mean, it's everybody's stuff, so get out and see it. And like I said,
How do you sign up for the Humpback Creek tours?
you go to the office and just let them know, put your name on the list.
Oh.
So next time we have a boat going out, they'll give you a call. You know, we try and let you know the week before, like, okay, we're gonna try and go out this day, depending on weather. You know, it's about a 15-minute boat ride out there. Well, thank you. And like I said, talk to your board members, because they're the ones that tell us what to do.